Let's take a look at section 2.2. In section 2.1, we were introduced to the idea of working with sets. And in section 2.2, we're actually going to look at different operations with sets. We're going to start out by looking at Venn diagrams. This is an easy way to help us to kind of visualize operations with sets. And so the way that we start out is by looking at our universe. And so we're going to look at an example first. And so in our example, we're going to look at our universe, which is all pets. So I want you to think about this box over here. And in this box, let's say we're going to put in any kind of animal that can be considered a pet. So a cat, a dog, a monkey, any type of reptile, a fish, anything that can be considered a pet could go into this box. All right, now we can also put groups into this box. So I'm going to say that my A group is going to be my cats. My B group is going to be my dogs. Now I can visually put them in as circles. And so I'm going to have my circles of A and my circles of B. Now notice that I did not overlap these circles. And the reason I didn't overlap these circles is because there are no cats that are dogs and dogs that are cats. So I kept these circles separate. So sometimes there are things in certain groups, not in particular in this case, I don't think, where you have pets. I don't know. Maybe there are pets that are considered more than one type of pet, but anyway. So you'll see that in some other examples that we're going to have where these groups are going to overlap. So you can put your cats in one and your dogs in the other. Okay, so this is a very simple Venn diagram. Now, let's talk about some operations that we can do with these Venn diagrams and sets. We're going to take a look at the most common types of operations between sets, and that is the union and the intersection. So the first one that we're going to look at is the union. Okay, so the union is when you take and you create a new set that contains every element of A or B. Now, the key word here is or. So a union is represented with this U shape here, and it has this or right here. So you'll see me talk about having or a lot. So again, this is an operation, so that's why we're creating a new set. So when you consider that, we're going to have everything that's in A or everything that's in B. So I can actually consider anything that's shaded in yellow here is going to be in this new set. That is my union. Okay, so that is a union. Now, the next set is going to be an intersection. So an intersection looks like an upside down U. All right, so an upside down U, this is called an intersect. And this is a new set containing every element of A and B. So rather than or, we have to have A. It has to live in A and in B at the same time. Now, over here in my diagram, if it lives in A and it lives in B, it's going to live in this inside section. And let me see if I can grab one of my tools down here to make that. So I shaded in this part right here for you that demonstrates the intersection. So it's this area right here in the center that demonstrates and shows the intersection. All right, so that is the intersection. Now we're going to take a look at one of your homework examples. The directions will say perform the given set operation, let U, which stands for your universe, equal 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Enter your answers as a comma separated list. Enter the word empty if your answer is the empty set. Okay, so they give you two sets. The first set is 1, 5, 9. And the second set is 5, 7, 9, and 10. They give you the operation U, which is for union, okay? So that means that you're looking for a union, which means or. So it's anything that is in this first set or the second set. So the way that I usually do this is that I go through and I list all of the numbers. And so I'm going to come down here and I'm going to create down here my new set, which is going to be my answer. So remember that your set is going to be in set notation. So I'm going to go ahead and put my answer in brackets. And so I'm going to first go ahead and put my 1. I'm going to put a 5 because I know that, and when I put my 5, that gives my 5 that was in both of these sets. I'm going to do my 9. Well, I'm going to put a 7. You like to put these in order, and so you want to put them in numerical order. So I did my 7 next, and then I did a 9, and then I did a 10. And notice I crossed them out as I went along so that I know that I got everybody. Okay, so I wanted to make sure that I got all of the elements that was in either set. All right, now in WebAssign, you are going to have your answer. It's going to look like this. They're going to already have the brackets down there and they're just going to have a box. So all you have to do is it says enter your answer as a comma separated list. So down here, you just need to type in 1, 5, 7, 9, 10. Okay, so just like that, that's how you would put your answer in there. You will not type in an extra set of brackets. I have a lot of students that will put another set of brackets in there and then they get it wrong and they get really upset. So just know that the brackets are already there. All right. Let's look at this next homework example. It's the same example of directions. You have the same exact directions and it's actually the same two sets, except for this time you're asked to find the intersection. So the upside down U is the intersection. So you're looking for and, in this case, you're looking for the numbers that are in the first set and the second set. So you're looking for which elements are common to both sets. So I'm going to look, and the first element that is common to both is the number 5. So that has to be in my intersection. The second element that's common to both is the number 9. So that has to be in my intersection. So then again, in WebAssign, you're just going to type in 5, 9. Okay. Let's look at one more example using the same universe. And this is a set that says the set of all x's such that x is a multiple of 2 with a union of the set of all x's such that x is a multiple of 9. Okay, so this is a union, so we're looking at either or. So I'm going to take a look at my set. I'm going to go through each of these numbers in my universe, and I'm going to ask myself, is that number a multiple of 2 or is it a multiple of 9? If it is, then it has to be in my answer. So is 1 a multiple of 2 or a multiple of 9? No, it's not a multiple of 2 or 9. Is 2 a multiple of 2? Yes. So that means it has to be down here. All right, so I have to put that down here. Is 3 a multiple of 2? No. Is it a multiple of 9? No. So remember, multiples of 9 is like 9 times 1, 9 times 2, 9 times 3, and so on. Okay, what about 4? Is 4 a multiple of 2? Yes. Is 5 a multiple of 2 or 9? No. What about 6? Yes, 6 is a multiple of 2. 7? No. 8? Yes. So 8 is a multiple of 2. 9 finally is a multiple of 9. And then 10 is a multiple of 2. So we have to include it. Okay, so that's going to finish that out. And then you'll know by now how to put that into WebAssign. Now we're going to take a look at a new terminology called the complement. All right, so if we are looking at the set A, so you have the set A, and then the complement of A, by definition, is a new set containing everything outside of A. So we notate that by this bar over A, so that's called the complement of A. And the way it looks is everything that's shaded. So outside of A, so all of this stuff in yellow, if it lives outside of A, then you are in a complement, or the complement of A. So a lot of times it's called a complement. All right, let's talk about some examples that go along with this definition. So for this example, you have the same universe that we've been dealing with, the numbers 1 through 10. And then they give you a set A, that's 1, 3, 5, and 7, and they tell you to find a complement. So remember, a complement is everything that's not in A. So if I go through here and I mark out everything that is in A, so 1, 3, 5, 7, then everything that is left is going to be a complement. All right, so a complement would be 2, 4, 6, 8, 9, and 10. 2, 4, 6, 8, 9, and 10. So that's what I would put into my answer. So that is a complement. So that's not that hard. You just have to know the definition. Let's look at another example. Same universe, except this time A is the set of all numbers such that X is odd. Okay, so the set of all numbers such that X is odd. So now this is actually a large set. So because A is actually an infinitely large set of numbers. However, my universe only contains these numbers 1 through 10. So that's good. So now all I have to do is look at the odd numbers that are in here. So the odd numbers, to remind you, 1, 3, 5, 7, and 9. So then a complement is everything that's left over. So it would be 2, 4, 6, 8, and 10. Okay, now we're going to look at more of a picture example, because you're going to have a few of these. And sometimes I have to kind of get my colored pencils out and kind of shade these out, and that helps me to see it. All right, so A complement intersected with B complement. So A complement. Remember, that's everything outside of A. So I'm going to come down here and I'm going to shade that out. So that's everything outside of A. Now I'm going to come over here and I'm going to shade out what is B complement. Okay, so B complement is everything outside of B. So that's everything outside of B. Now, remember that the intersection is everything that is in both of these at the same time. So if you were to kind of be able to shade on top of each other and combine both of these pictures, that's your answer. So that's where you have to kind of really look at what that would look like. And so I tried to combine that into this, and that is what I ended up getting here, I think. So in this particular case, we know that this inside part is not in either one of them, okay? But for example, this part over here, this part of B right here, it's in this shaded part, but it's not in this shaded part, so it can't be in either one. And the same thing goes with this little part of A, okay? So, but these outside parts and the edges are in both of them, so it has to be in the intersection. All right, so hopefully you can kind of see that. In WebAssign, this is like a multiple choice question. We're going to finish up this section with a couple of word problems. And you have some word problems in this section that, that are going to test you and kind of test some of your patience on this. So I decided I would take this back to our church example. So your church has 75 members. 12 members serve as ushers. 17 members serve as greeters. 6 members serve as ushers and greeters. How many members do not serve as either an usher or a greeter? Okay, so in these problems, what I can tell you is that for this problem, we're going to start with the most specific information and work our way backwards. Okay, and so in this case, the most specific information that I have is that 6 members serve as ushers and greeters. And so in my Venn diagram, they are going to live right here in this center part. They serve as ushers and greeters. So I'm going to go ahead and put them right there. 6 of them live as ushers and greeters. All right, now I'm going to try to kind of fill in the rest of my Venn diagram and kind of work my way out of here. So then it says that 12 members serve as ushers. So if 12 members serve as ushers, but I know that 6 of them are in here. 6 of them are ushers and greeters. So I have to say 12 minus 6 because 12 serve as ushers, but 6 of them are also greeters. So 12 minus 6. So out here in this part, I know that that has to be just 6. So 12 minus 6 would give me the 6 that live in this part of the circle. Okay, then I'm going to look at my greeters. 17 members serve as greeters. So, but 6 of them live here because they serve a dual purpose. So I'm going to say 17 minus these 6 will give me the ones that live out here. So that would give me the 11 that are out here. All right, so I'm almost through with this because now that's going to give me, I want to know how many people are not doing anything. How many people are not serving as a greeter or an usher? How many people can I go and ask them to do one of these things? Okay, so to figure that out, I'm going to take the 75 members that I have left, and I'm going to subtract these 6 people, these 6 people, and these 11 people that are already doing something. And that's going to give me 52 people that are living out here that are not doing anything serving as an usher or a greeter. Okay, so that's going to help me to know that I have 52 people that I can pull from and go and ask. So that's the answer, is 52 are not serving as either an usher or a greeter. Okay, so that's the answer to that question. All right, this is our last example. This is your homework example number 16. It is the one that I always get the most questions on, and rightly so, because it is difficult. This is one that you will need a calculator for, so I suggest that you take good notes on this, and you probably are going to want to watch this video a couple of times for this problem. So let's read the problem first. A certain college enrolled 36,000 students in the fall of 2015. When this data was collected, it was reported that of that number, 53% were female and 47% were male. In addition, 62% were over the age of 25. How many students were there in each category if 30% of those over the age of 25 were male? Draw a Venn diagram showing these relationships. Okay, there is a lot here, and they gave you a Venn diagram that looks very intimidating. And so if you were like I was when I first read this, I had to read it 2 or 3 times and really look at this diagram, and that is perfectly fine. Read it as many times as you need to, study the diagram, and just sometimes you have to read it and come back to it, and that's okay too. Take your time on it. Okay, the first thing I'm going to do on this one is that I'm going to kind of just try to take it piece by piece and just see where it leads me. And that's how I approached this problem. So the first thing I did is that I looked at this number. 53% of the 36,000 students were female. And so I wanted to know, how many is that? So I grabbed my calculator, and what I did, and what I'm going to do is kind of over here off to the side, I'm going to list all of these calculations. So that way you'll know exactly where these numbers are going to come from. And I would suggest that you do the same thing, okay? So 53%, just to remind you, how you figure out percentages is that we're going to take this total number, 36,000, and we're going to multiply it by 0.53. So that's 53% in decimal form is 0.53. And when you do that in your calculator, you get 19,080. All right, so you should verify that with your calculator, but that's what you get. So it says 53% were female. So I'm going to go ahead and do that, and then I'm going to write it down that that is the females. All right. Now, if that's the females, you have a couple options with the males. You could do the same thing that we just did with 47%, or you can just say, well, if 19,080 of them are females, then I could subtract, and that's what I did. I just said, okay, 36,000 minus 19,080 gives me 16,920, which has to be the males. All right, so I'll let that kind of sink in for a second. So now that I know that half of my population, or I've got the part divided, that I know that I've got 19,080 females, 16,920 males. And what I did is I went ahead and I kind of put those numbers over here on the chart. Now, I put them on my Venn diagram, but I did not put them inside the diagram. And the reason I didn't is because this diagram is detailed, okay? So when you look at this diagram, you've got the females are on the right side, the males are on the left. But you've got the ones that are inside the circle are students over 25, and outside the circle are students under 25. So I didn't want to put this number anywhere inside this box because I don't know what part of this number goes where. Same thing over here with the males. So I just wanted the numbers to go where they were supposed to go. Okay, hopefully that makes sense. All right, that's all I got for now. So that knocks out the information 53% and this 47%. But that gives me a good bit. All right, in addition, 62% were over the age of 25. Okay, let's do the same thing then and figure out what kind of number are we looking at for that. So I'm going to take 36,000 and figure out what is 62%. So I take my calculator, multiply 36,000 by 62%, and I get 22,320. So I'm going to label it. That means that's how many students are over 25. Okay, students over 25, 22,320. So in this Venn diagram, all of this big circle, that's how many lives in the circle all together. Which is great, except I don't know which ones live on which side yet. But I'm just going to let that soak in with you for a second. 22,320 are over 25. Okay. Now, then it tells me 30% of those over 25 are male. Okay, let's wrap our mind around this. 30% over 25 are male. All right, over 25, 30% are male. So 30% of this number is male. So now I need to do another calculation of 30% of this. All right, so I'm going to come down here, and now I'm going to say 22,320 times 30%. That gives me this number right here, 6,696. That's over 25, and they are male. Okay, I'll give you a second to write that down. I took 22,320. I multiplied it by 0.30, which is 30%. I got 6,696. And that represents the people that are over 25 that are male. Okay, This is my first answer for one of these boxes. So when I look at this box over here, inside of this circle are my students over 25. And the left box are the males that are over 25. And hallelujah, I actually have an answer. 6,696. So I'm going to put that number in there. Now, if I only knew how many total students were over 25, I could just subtract this number from it to get the females. But wait, I do know the total number over 25. We figured that out, right? Here it is. 22,320 are over 25. If this is the number of males, all I have to do is subtract the males out and you get the females. Okay, so that's going to be my next step. I'm going to say 22,320 minus 6,696, and you get 15,624. That is over 25 female. Hallelujah. I have another answer. $15,624. Now, can you think of a way that we could find this answer down here? So if in this circle is the students over 25 females, this would be students 25 and under. If I only knew how many females total we had. Oh wait, I do. We figured that out first. Here it is up here. 19,080. So all I have to do is take that number and subtract the 15,624, and I get 3,456, and that's going to be my female 25 and under population, and that's the number that goes in this box. And now if you want to pause the video and see if you can come up with what goes in this box. So hopefully you came up with that you took 16,920, which is the total number of males. You subtracted 6,696, and you got 10,224 males 25 and under. And that finishes out our problem. Now I realize that's a lot of numbers, and you might have a headache by now. So you may have to watch this problem a couple of times for it to really sink in. But hopefully whenever you're working through it and work through your homework problem, work through it with this example, and you'll have different numbers for your homework problem, but it will work very similar to this. All right, if you have any questions, need any help, please let me know.